this is, I'm just looking at like a, instead of printing a copy for everybody, I just printed one and I'll put the context up here. This is fire station response times. There's a north and a south fire station. And we're supposed to do a 95% confidence interval to estimate the difference. So we're doing two sample T interval today. Yesterday was the test. This is the AT. Grab your calculator if you have a second. So you start off by defining what we're after. So I would do like, I'm gonna do mu n for like the north. You can do mu one, mu n, whatever you want. So I'm just saying mu sub n is the true population mean response time for north, and then mu sub s for south. And then, like I said yesterday, if this stuff weren't already here, I would probably write most of that down like below, just as kind of an organizational thing, like here's all my stuff. But I'm not gonna do it because it's all right above. So our conditions. I think I'm forgetting something. Is there something else I did before the conditions? That's the HO and HA. We're not doing that. Yeah, okay. So shape. We need one of the three things. We have the easiest one probably, but let's just remind ourselves of all three. So we have n is greater than or equal to 30, so we're good. What are the other two that we would, what's the other like friendly one? Normal population, and if you don't have one of those two, maybe you gotta make the dot plot. But we do have, so I can say both samples are greater than 30, greater than or equal to 30, so we're approximately normal. So for your center, we're comparing two things, which means we're subtracting them. So you gotta decide, it doesn't matter. Are you gonna do like x bar sub n minus x bar sub s, or the other way around? I'm gonna do south minus north, just because my brain like works a little better. Because when I subtract those, it's a positive number, it's kind of like easier to process. So I'm gonna do x bar s minus x bar n. If you want to do it the opposite, it's totally fine. It might be a good idea. Then you can like see how it would shift at the end. So this, the way I'm doing it would be 5.2 minus 4.3 or 0.29. Why am I allowed to use that? Oh, it says in the problem that I read. I just didn't write it down. Because randomness. say you would just assume, but it's. And then the spread, which shows independence. That would be the 10% thing. So like 50 is less than 10% of all north responses. And then 50 is less than or equal to 10% of all south responses. Alright, and then we do, so for a test, we'd have like t equals, and we'd have the equations. But for a confidence interval, if you remember, it's statistic plus or minus critical value times standard deviation. So our statistic is like our best guess of what we think the difference is, and that's our subtraction up here. So in symbols, you're supposed to go words, symbols, numbers. In symbols, it's the whatever you put up here. So if you did north minus south up here, you put north minus south down here. That's your statistic. T star or Z star? T, why is it T and not Z? Okay, why is it T interval? You can't say because I told you. Because we're dealing with means, right? So proportions are Z and means are T. And then the standard deviation is that big, you'll have like the standard deviation of north squared over n north plus the standard deviation of south squared over n south. Now let's discuss it. So that's with words and then symbols and then numbers. So this would be where I'd say, okay, that's 5.2 minus 4.3. Then T star presents an issue. So what I have to do now is I can fill in these, I guess. But we're gonna have to go to the calculator to get this T star. So we're just gonna run the thing, like have the calculator run through it, do it, and then we'll come back and put T star because I don't know how to figure that out without that. So then I'm just gonna fill in this, and then we'll come back. So the the north standard deviation is 3.7. That gets squared divided by the sample size. The south standard deviation is 3.2. That gets squared and divided by the sample size. So now we're gonna go to our calculator, have it do the interval for us. It'll tell us T star. We'll go back and fill in that, and we'll be able to put our interval there. So grab your calculator, stat tests, and then you want 2 sample T interval, which is down. It's like number 0, like 67890. I'm not sure if I should be showing the paper right now or the calculator. Logo calculator. So stat test, and then scroll down to 0 for 2 sample T's. And then put in our stuff. So I did south as my 1. You might not have, so just pay attention to what you did. So that's the information for south. So I'll shut up and let you guys do it. Confidence level 0.95. Not pooled. Imagine pooling. And then if you header, it should give you the interval and the T star, or it doesn't give you T star, it gives you degrees of freedom. So off to the side, write down like degrees of freedom equals 96. My fault. We have to backfill this like twice. It's like 2 steps. And then there's our answer too, right? So it's negative 0.473 and 2.27. You see it? So then if I know my degrees of freedom, to find that, I'm going to go inverse T 1.95 divided by 2, comma 96. I was writing 96. And like, you don't have to write this part on your paper, right? I'm just doing it to show you. You can. I'm just doing it to show you what I'm doing. So if I do inverse T 1.595 divided by 2, comma 96, and I got the 90, the only way I get the 96 is by running through the test. It's thinking, all right, give me 1.98. You guys get 1.98, you see where that's coming from? Okay. No, you got beef. Okay. Questions yet? All I got is the conclusion. So then I'm just going to say, like, we are 95% confident. That, and I'm going to say mu n minus mu s. No, I did it the other way. Mu s minus mu n is between, and then, write the numbers. I think it might be helpful, like, now that I've run through it, we have to write down here, like, we would usually say that mu is between, or like, p is between or whatever, but this is like a subtraction one. You do have to put that subtraction down there, like the us minus mu n. It might, and I got the order from what I did here, but it never actually says mu s minus mu n anywhere. It might, and it doesn't have to for my sake or the grader's sake, but it might be a good idea for you to just kind of write down at the top like the order that you're choosing, and then follow that through the whole way. Not required, but just like to keep your process straight. Questions in there anywhere? Alright. So you guys want the template next usually? Alright. Two sample T interval. Everybody know what BRT is for today? Or if there's anything? Wait, what?
I don't know if there's anything.
Okay, so you're gonna have like mu1 or mu2 or mu-a, mu-n, whatever you're deciding is the true population mean of the context, like context 1, you want to say that? And then mu2 is the true population mean of the other context. And then I do think it's a good idea, like I was just saying, to put, you can decide the order, but I think it's probably smart to write like which order you're gonna do. And then I'm just putting like 95% there, or I guess it's a template, so it'd be like blank percent. And that's just like for myself to kind of organize my thoughts, so I technically you only have to write things once, and you will write this at the bottom if you're doing it right, and you write this at the bottom if you're doing it right. But it doesn't hurt to write it twice. So then we do our conditions. The shape is the more annoying one because you got three things to look out for. So remember, you could have n is greater than or equal to 30. And these all need to be true for both. And if not, I'm sorry, they don't all need to be true. At least one of them needs to be true for both. And if we know that, then we can say it's approximately normal. So 1 is n is greater than 30. 2 is, don't make Owen say it again, he says it every time. Approximately normal population. I got you. And then 3 is the dot plots. Don't have skew or outliers. So again, usually you'll get one of the top two. You can just say it, but if you don't get one of those, you have to make a dot plot. And just say like, yeah, this looks fine. So the center is going to be whatever the order that you decide. So I wrote mu1 minus mu2 up there, so I'm just going to keep it that order. But the center, I can't say the center is mu1 minus mu2 because I don't know those. I don't have like the population mean. I got to say the center is x bar 1 minus x bar 2 because the only thing I have is the sample data. So that equals whatever, as long as we have randomness. So you have to actually be able to do the subtraction as a way to remove that. If you put mu1 minus mu2, you can't subtract numbers because you don't have those numbers. So you want to be able to get a number there. And then spread independence. You want little n is less than or equal to capital N. So that's supposed to represent like little n is the sample. Samples are smaller. Capital N is the big picture for both. Alright, then we got words, symbols, numbers. So statistic, plus or minus critical value, times the standard deviation. Your statistic is whatever this was up here. So whatever order you used. Your critical value is T star. That's what you know what it means. And the standard deviation is that log formula. Hello? Hello? Like right now? Okay. Yeah, but. Go to your office. And then there's the standard deviation. So there's the standard deviation of the first thing squared divided by the sample size. The first thing, the standard deviation of the second thing squared divided by the sample size. And then we're going to put in the numbers. So let's do like, I'm going to put plug in numbers. To get T star, you got to run the test to get the degrees of freedom. And then you do inverse T 1 point whatever divided by 2, comma the degrees of freedom. And so you will have a bunch of numbers there. I'm trying to keep the pattern of like words, symbols, numbers, but then I tried to put a little note in there. And then you'll get your answer. And you'll say we are blank % confident. What do I put here? What's the next? What's the next phrase or symbols? What am I trying to estimate? Like, what's the point of this? Before that, the mu1 and mu2, yeah, the mu1 minus mu2 is between, you know, whatever you got. Forgot on this one, you don't have to go back to anything, I'm just gonna go back. There was a part B on this Frappy, and we've talked about it before. Let me just read the word. Does the confidence interval in part A, which is this, support the belief that the 2 fire stations have different mean response times? Does this interval support the idea that they're different? Does not, why? Because 0 is included. And if they're actually the same, 0 is what you get when you subtract it. 0 is a reasonable number, so they might be the same. Not proving that they are, I'm just saying that's reasonable. So often on these you'll get like that follow-up question. Questions? Alright, you guys are gonna do one. Sorry, I didn't see. So we're going to estimate the true difference between AP Stat scores and AP Calc scores. This is like throughout like my teaching career. So you know, like 10 is less than 10% of. Let's say that. We did it randomly. Populations are normal. Do I work? No, I have to do it. Is everybody still writing this? So if you care what I'm doing, I'm going to do stats minus calc. Again, just because I prefer a positive mean if I can get it. It's not any more right or wrong, it's just personal preference.
left in the negative. You know?
Like you feel the panic of the actual test in
Yeah.
practice.
It seems
Not
to.
good or bad? What?
It's good.
That's good.
Doing okay.
You what?
I tried to drop 32.
Instead of like running the actual assembly, just do the drawing screen.
Yeah, I don't think so.
There's not a new one though.
There's just
There is a new?
there's you and then there's me too.
Is that like the evolved version of the new?
No, yep. Well, yes, it's a clone, but like, yes. I mean, they're not
My
the
son
same.
got Ditto
They're
last
both
night.
basic. Well,
He did, I Pokemon Go. I was all excited. He got Ditto. Did you play Pokemon Go?
I played Pokemon Pocket.
Civil.
It's like there's cards. You don't go around collecting Pokemon, you just have cards.
This is my son. He sits on his freaking couch. Oh, there's one in the yard.
I have Pokemon Go on my phone. And I play.
The cemetery was much of that.
Kroger.
Like the Pokestops and stuff. Really?
Because
Oh,
my
so
mom
yeah,
used to
they're
just
all-
literally drive and park in the cemetery.
No,
And
there's
sit
a
there
gym
for
at
like hours.
McDonald's, so I should
Weird.
really start.
Like that's, we're encouraging kids to hang out at the, I don't know. Yeah, we'll just be driving it. We got soccer.
Sometimes goes to cemeteries, oh, we used to, there's like, stand up, there's a cemetery that's like huge.
So it's like, impressive stuff.
Cemetery, just family.
Like they don't want you to walk on the ground.
So it's like huge, so if you get out, you can only go so far before you come back. And there's also, it's mostly the roads, the traffic, so
Any questions I can answer on it? If you got this, you're good. That's all we're doing today. Any questions I can answer on it? Alright. Let me know if you have one, and then we'll keep going tomorrow. Like I think I mentioned to you guys yesterday. Plan is reviewed. Did I mention this? Plan is reviewed tomorrow, Friday, Monday, and then test Tuesday. And then you'll probably have time to work on your take home test in class up until Tuesday. heat
Warm
in my
is when
room.
it's easy at the beginning
Oh,
of
I
the year,
hear
and
it.
warm is when it's
I like it when it's hot.
Especially if it's 50 out. So now like Friday to like Sunday.
How does that even happen?
Exactly.
One day
That's actually crazy work.
We've added 30 degrees to the outside temperature. Are you good?
Yeah, I'm good, thank you.
I like how he kept those.
I get very whiny when it's hot.
I would say. I like how he kept Ray this summer for the hottest day like ever.
Wait till you see this summer.
This summer is gonna be like.
It's only getting worse.
We should see like just how like for fun how hot we can really get.
I don't think we have.
I was gonna say,
Point.
we just like sit back and